So today we're going to continue learning about piecewise functions. We've kind of introduced these. They may look kind of like this one where you have, looks like part of a parabola and part of a horizontal line there. They're little pieces, right? So they're called piecewise because they're pieces of a function. You don't see the full parabola. You don't see the full line there. You see only parts. Notice one thing, they don't overlap. What I mean is vertically. Like if you were to draw a line and kind of move that around, you can see that it only crosses one function at a time. Here it's crossing the line, here it's crossing the parabola. Even right there, straight up and down from there, they don't even overlap right there. Before we get too much into piecewise though, I want you to know these four graphs by heart. It's really going to help you in the lessons going forward to do that. So let's go ahead and learn them. And so we're just going to plot a few points here like we did in the last chapter, x comma y. So if we plug in, say, 0 for x, we get 0 for x, we get 0 squared, which is 0. So we have a point right there. It's one of the famous points on this graph. We plug in a 1. 1 squared is 1, so we get 1, 1, 1. Plug in 2. 2 squared is 4, you get 4, 2, 4. These are the famous points on this graph right there. Let's plug in negative 1. Negative 1 quantity squared is going to be a positive 1. And then negative 2, we plug that in, you get a positive 4. So pretty soon our graph is going to look a little bit like, and I don't know if I'm drawing this exactly perfect, it's going to be a parabola, right? It's got a little curve to it down at the bottom. And it's going to go through those five main points. I would definitely have these ordered pairs memorized. 0, 0, 1, 1, 2, 4, especially those. Those are just the negative equivalents right there. But you need to know those 5 points on that graph. So that if I say x squared, you just go boom, 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 catch your graph, right? Just graph your points. Let's try another one. So let's graph this one. So we've got a chart, x and y. Plug in 0, you get square root of 0, or absolute value of 0 is 0, so that's that point. Absolute value of 1 is 1, that's easy. Absolute value of 2 is 2. I see kind of what's happening over here, going to the right. And then let's plug in negative 1. The absolute value of negative 1 is actually a positive 1. So it looks like this. Absolute value of negative 2 is 2. And pretty soon you see the pattern going that way. I would definitely have memorized these 5 points, or at least these 3 points. And these are just the negative equivalents, which are 1, 1, 0, 0, 2, 2. They're actually pretty easy to memorize. And understand this, when we have a graph called an absolute value, I kind of emphasize the V in value. Why do I emphasize the V in value? Because all absolute value graphs have some kind of V in them. Do you see the V? There's the V for absolute value kind of thing there. Ah, it's nice. Memory trick. Okay, let's do 2 more. You need to know these graphs. So one of these will be some points here. This is the cubic function. So if I plug in 0, 0 cubed is 0, so I got that point. Plug in 1, 1 cubed is 1. Here's something different. If I plug in 2, 2 to the third power is 8. So 2 comma 8 is a point. You need to know those 3 points. Plug in negative 1, it will be different. So negative 1 to the third power is actually a negative 1. So that's negative 1, negative 1. Negative 2 to the third power is negative 8. Negative 2, negative 8, and pretty soon you have this nice graph that's appearing. Looks something like this. Oops, doesn't have that little wrinkle in there. I don't know if I can get that out or not. It looks kind of like that. Just get it straight up there. So it goes down a little bit to the left, up, and a little bit to the right forever. And it kind of looks like a really steep parabola, but only half of it, and here's the other half of the parabola kind of there. Although it's not quite a parabola. Looks similar. So again, know these points, 0, 0, 1, 1, 2, 8. maybe know behavior of the negative, and you'll be fine on that one. So square root. Square root is a very popular graph. So let's kind of build this one and see what it looks like. So plug in 0, square root of 0 is 0. Plug in 1, square root of 1 is 1. That's easy. 4 for x. If I plug in a 4 there, square root of 4 is 2. So I have the point 4 comma 2. You probably see what's happening over here. But then when you plug in, say, a negative, let's see, a negative 1. Square root of negative 1 is I. Is that a real number? So even though you get an answer there, it's I, we can't graph that. So really, this is the graph of the square root function. You need to know those 3 points and know the behavior. It starts here, keeps on going to the right and up forever. Okay, now that we have those basics, we're going to learn a little bit more, and this is going to help us, I think, with the basic shape of this guy. So let's plug in some points here. The way I want you to do this, the method I want you to use when you graph this, when you're starting out, just graph the whole line to start with, right? We're just going to graph, or the whole parabola. In this case, we're going to graph this parabola here. So I'm going to do x and y here. So I'm plugging into this guy first. So I'm going to plug in like 0 here. This will be 0 squared minus 2 is negative 2. If I plug in 1, I get 1 minus 2 is negative 1. Plug in 2, 2 squared is 4, 4 minus 2 is 2. 3 squared is 9, minus 2 is 7. Okay, let me see if I can plot these points. So 0, negative 2, 1, negative 1, 2, 2, 3, 7, somewhere way up there. So it's getting off the frame there at that point. Let's plug in maybe a few negative values. How about negative 1? Negative 2. Let's see, negative 1 would be negative 1 squared is 1. 1 minus 2 is negative 1. So negative 1, negative 1. Plug in negative 2, that's positive 4. 4 minus 2 is 2. So negative 2, 2. And if we plugged another one, it'd be way up there as well. So you can probably see the parabola forming. It looks a little bit like that x squared parabola. Looks something like that, roughly. Okay, so the key is here, I only want a certain part of that. I want that graph when x is less than 1. When x is smaller than 1, I want this graph. So x is 1 right here, anywhere on this vertical line. So I don't want the part to the right, I do want the part to the left. I want all of this. I want that. I'm going to take my eraser and erase the right-hand part here. And always be really careful about this point. Right there, is it open or closed? It says less than. What that tells me is that this will be open. So we got an open circle there, graph to the left. Okay? Let's graph the next one. So let's do a chart for this one. Not quite as hard. There should be a linear line. Or you might be able to graph this. Let's graph this without a chart. I think it'd be easier. So the y-intercept is negative 4. I always start with the y-intercept. Slope is 1, or maybe I should say 1 over 1. Rise of 1. Run of 1. Looks kind of like this. I'm making a whole bunch of slope points here, so I don't have to use a straight edge when I draw my line. Because of those points, I should be fine. And let's see. Sorry, just drew like a vector line. I want to get rid of that. So I need to talk about which part of that line I need. Well, I need it when x is greater than or equal to 1. So here's x is 1, anywhere on this vertical line. I want this part where x is greater than or equal to 1. I don't want this part over here. When you get to that point, be careful. Should I put an open or closed circle there? Let's see. That's a greater than or equal to. That means closed circle. So my graph's going to look something like that. Again, the pieces will not overlap vertically. They just won't when you do that. Let's try another one. This one should be a little quicker. So when you're doing something like this is f of x equals 3. Remember, think of this as y equals. So it's like f of x is like y equals. So y equals 3. Well, y equals 3, we've done a bunch of those. That line looks like this. Right? It has a y-intercept of 3, and it spans the whole space there. I only want that function when x is less than 2. So I want a little bit less than 2 all the way over there. I'm going to erase a few things. Oops. When you get to there, you can see that this is open circle according to that. So this is going to be an open circle right there, and that's your graph. That's when the domain, the x values, are 2 or less than 2. Actually, just less than 2, not equal to 2. That's why it's open. Let's do this one. So we got negative x plus 4. Start with a y-intercept of 4. Negative x means a slope of negative 1. Looks like it goes here, 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 all the way down. Drawing that a little sloppy. It's got a little curve to it. It should be straight. Linear line. Gotta redo that. Let me use my tool here. How about this? Okay. It's beautiful. Okay. So I've got these two lines. Oh, but I don't want to. I want to erase part of that. So I don't want this part of that line, right? All I want is that line when x is greater than or equal to 2. So right there, 2. I really want this to be, oops, it's not writing for me. There we go. It's going to be an open or close. Let's see, closed circle. So closed circle. Add 2, and arrow goes down. And this goes up, down forever. Right. So that's my piecewise function. Again, they don't overlap vertically, and you got it. Let's do another one here. So in this case, and I'll just tell you a little hint here. When you have a negative out in front, what it does to that function is it takes that, you had like these 5 points here. You had like this point, this point, this point, this point, and this point. If you take those points, sorry about that. If you take both those points and grab them, well, what's going to happen is this one's going to move down, this one's going to move down, this one moves down, and this one moves down. Because you put a negative front, the y value will now be negative instead of positive. So it takes all those points. See, it helps to kind of know the parent graph, and we'll get better at that as we go here. But that graph looks something like this. Bring this up here a little bit. There we go. Okay, so we got our graph of that, but we need to erase part of it. Right? Because it says that we only want this graph when x is greater than or equal to negative 2. So I want this graph anywhere here I want, right? But I don't want this graph when x is negative 2 or smaller. So I'm going to erase this part. I'm going to make sure to make this a closed circle right there because of that sign. It's equal to. So that's the first half of the graph. Looks something like that. Let's graph the next half. So this would be y-intercept of negative 3. Slope is 1/2. That's up 1 over 2. Up 1 over 2. Up 1 over 2. Go ahead and make your line. Oh, I don't need that whole line though, do I? Right? I only want that line when it's smaller than negative 2. I want this part. Here's what's weird. It actually touches right there, doesn't it? If this were a thing, it would be a closed circle there, but it's an open circle because of the green, but because of this guy, it's a closed circle. So they actually have to happen to touch there. That doesn't usually happen. Get rid of that guy. There we go. That's your piecewise function for this one. So I think you're ready to try some on the homework and see how you do.